So question 1 is that a yogurt shop offers 3 different flavors of frozen yogurt and 13 different toppings. How many choices are possible if you are only allowed one topping? So I have 3 different flavors of yogurt and I have 13 different toppings. If you think about this, if I was to draw a decision tree, let's say it was strawberry, chocolate, and vanilla, and I have 13 different toppings and I'm allowed to pick one, I'd have 13 little lines coming off here. I don't know if that's 13, but you get the point. 13 coming off here, and 13 coming off here. So how many choices would I have altogether? I'd have 13, 13, and 13, which is 39. You may not come to it that way. Again, most you should be comfortable now choosing outcomes, determining the number of outcomes by looking at the number of choices you have. So I have to make 2 decisions here. Which flavor and which topping. How many choices do I have for each? I have 3 for my first choice. I have 13 for my second choice. And that's 39. Question 2. A dinner menu at a restaurant offers 4 kinds of appetizers. So again, it's the same question. Appetizers, that's one decision. Main courses, that's another decision. And desserts, that's another decision. A dinner consists of one of each. How many combinations are there? I can have one of 4 appetizers, one of 7 main courses, and one of 4 desserts. And I'm just going to multiply those together. And when you multiply those together, what do you get? 4 times 4 is 16, times 7 is 112. Now, in this one, it would make no sense to do a decision tree. It would just be so big by the end. So that's why you need to be able to kind of do this multiplying method. First choice, appetizer. Second choice, main course. Third choice, dessert. And I just think about the number of choices I have for each one. So question 3, coin and a dice. What's the probability of throwing a heads and multiple of 3? So the first thing you need to understand is that 3 and 6 are both multiples of 3 in this question. So there's no 9 or 12 because we're only rolling one dice. Here's what could happen. For the first choice, I flip a coin, it could be heads or tails. For the second choice, it could be one of the 6 outcomes for a dice. It could be 1, 2, 3, 4, 5, or 6. And the same if I was to go tails first. So really all this does is show you what happened. I flipped a head and I rolled a 1. I flipped a head, I rolled a 2. Flipped a head, rolled a 3. I flipped a tails, I rolled a 5. And these are all the things that might have happened. So it's sometimes smart to label these. Head 1, head 2, head 3, head 4, and so on, all the way down until you get to tails 6. So it asks, what's the possibility that coin is heads and the number is a multiple of 3? Well, in order to know probability, we need to know 2 things. Favorable outcomes and total outcomes. Total outcomes is easy. We can just count those right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total outcomes. 12. How many have heads? Well, I know none of these are going to matter in that case. In terms of determining our favorable outcomes, none of those will matter because I did not flip a head. So let's look over here. The heads. How many have a heads and a multiple of 3? That one and that one. Heads 3 and heads 6. So 2 out of 12 or 1 out of 6 if you were to simplify it. That would be your answer for question 3. Now, there is an easier way. And the easier way involves a little bit of common sense. I know it's going to be heads. And I know the multiples of 3 are 3 and 6, so I really know already that there's 2 favorable outcomes. If I know that, I just need to figure out how many total outcomes there are. And I can do that this way. These are my coin flip choices. These are my dice rolling choices. There are 2 different choices for flipping a coin, heads and tails. There are 6 different ways I can roll a dice, and that's 12. So then I would know 2 favorable over 12 total equals 1 over 6. That's easier, but you'd have to write out a bit of an explanation for it. So question 4, Grace wants to know the probability of a family of 3 children having 2 boys and a girl. She tosses 3 coins with a head representing a boy and tails representing a girl. Use a tree diagram to list the possibilities and state the probability of 2 boys and 1 girl. This is a lot like question 10, and it really kind of describes how you would do that simulation, but she's just doing it kind of one time, and she wants the theoretical probability, whereas the simulation would talk about experimental. So, first thing that we need to do is draw our tree diagram. We have heads and tails as our possibilities. Heads and tails. So heads might happen for the first kid. Then we're going to have our second kid. Heads and tails. Then we're going to have our third. Heads and tails. 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 So, looking at this, if we know that heads is a boy and tails is a girl, we can figure this out. This is 3 boys. This is 2 boys. This is 2 boys. This is 1 boy. This is 2 boys. This is 1 boy. 1 boy and 0 boys. So, we need to now figure out how many. This lists all the possibilities right here, and use a tree diagram to find the probability of 2 boys. So how many of 2 boys? This one, this one, this one have 2 boys. So remember, when we're talking probability, it's favorable outcomes over total. Favorable is the one we're studying. That happens to be 3 of them. And there's 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. So that's that. So this would be my probability, 3 over 8. Now, understand when I talk about favorable outcomes, I'm not talking about which ones are the best in real life. I'm just talking about favorable means the one we're considering. So we were considering probability of having 2 boys, so that is favorable in this particular question.